And there's several different ways to do both of these, okay? Some are more pleasant than others. Got him now? Did you show all your steps? Are you sure? Did you write the problem down? Okay. You'll do neat and organized work for me on your test, right? Okay. All right, guys, another minute, then I'll go through them, okay?
Oh.
Are you ready, guys? Or you need a minute? You need a minute? Okay.
Oh.
Did you get anywhere?
I got very close.
On both or on?
I finished the first one.
Okay.
The second one's missing.
Okay.
That's a lot. This cancel as many times.
All right, guys, let's look. Now, there are a lot of ways to do these. The first one, you certainly could find a common denominator and then do your Pythagorean substitution and go from there. I'm going to do the Pythagorean substitution first. So sine squared, I'm going to turn into 1 minus cosine squared. Then I can factor that. And what can I get rid of? 1 plus cosine. And then just be careful with your negative here. What is 1 minus 1? You can even write it out. This is going to be 1 minus 1. And then do you see how it would turn into plus cosine? Yeah. Okay. So you're left with cosine. There are other ways, yeah. I just think that was easy. How many got the first one in one way or another? Okay, pretty good on that one. All right. The second one, I saw some interesting things on this. Some of you found common denominators and multiplied everything out, and that will work. I'm going to do something a little different. I'm going to leave this first fraction alone. And then in the second one, I'm going to make a substitution in that denominator. What is tangent squared equal to?
Sine squared plus sine.
What else is it equal to? Yes, secant squared minus 1. Okay.
Oh,
Then can I factor that denominator? Yeah. Try to squeeze it all in here. So the numerator is just secant theta plus 1. Denominator would be secant theta plus 1, secant theta minus 1. Okay. What happens? Cancel out. What is left in that numerator since those canceled out? Okay, a 1.
oh,
Do you see how they now have a common denominator? Do you guys see it?
yeah.
Yeah, so it's going to be secant theta minus 1 over secant theta minus 1. And what is that? It is not tangent squared over tangent squared. They're not squared, so you can't use the Pythagorean identity. It is just 1. Okay? Lots of ways to do both of those, but those two ways work. You guys are getting better at least like trying things and finding different paths. There's less sitting and staring happening right now, so that's good. So what I had, just that part of it,
Right here. So, you just compound this.
what happens there?
Secant minus 1.
Okay, so what am I left with?
Oh, okay, yeah.
Yeah. Yep. Other questions? Okay, then let's move on to notes. Last set of notes.
I think it would have worked, but it's all those things do the steps correct. Mine is just gonna take a long time.
You're taking the scenic route on everyone?
Yeah, it's a lot of numbers.
Did you like multiply everything or?
Yep.
Okay. It can work. Okay, guys, so we have more formulas to learn. We'll derive some of our formulas today. So let's start with, label them for you, the double angle formulas. So we'll start with sine of 2 theta. So that's, I doubled the angle, right? I took 2 times the angle. All right, this is really the same as sine of theta plus theta, right? That's what 2 theta means? No? Yes? Yeah.
Does that say, what's the first word in angle, like something angle formula that I can't double?
Double.
That's double?
D-O-U-B-L-E. You want me to-
Oh, the L and the B are just like right next to each other.
They are.
Thank you.
Is that better?
Yeah.
Now the L and the E are kind of close. I don't know. Yeah, double angle formulas. We're also going to learn half angle formulas today. Okay. All right, you should know the formula for sine of theta plus theta. What could that turn into?
It's sine theta. Sine theta plus cosine theta.
Oh, okay, kind of weird, right? You end up with sine of theta, cosine of theta, plus sine of theta, cosine of theta. Okay. So that is your first double angle formula. It is 2 sine of theta, cosine of theta. A lot of you look puzzled. Okay, so I'll write it this way.
Oh, so my bad.
Sure. No, you're right. Like we did write it with the cosine first, so. But you see they're still the same, right? Okay. Greta? I mean, it's multiplication, so no. I'd just be consistent for yourself so that you remember it. Okay. This one's just weird because the angles are the same. Okay, now we're going to do the same thing for cosine. So cosine of theta plus theta. So what is that going to expand into? Okay, yeah, because you end up with cosine theta times cosine of theta minus sine of theta times sine of theta, which is cosine squared theta minus sine squared theta. Now, with that one, we could actually write that in a couple of different ways. Because it has the cosine squared and the sine squared in it, we could do some substitutions with Pythagorean identities. So, what could I replace cosine squared with? 1 minus sine squared minus sine squared theta, right? You guys see what I'm doing? So another way you could write this one is 1 minus 2 sine squared theta. That's another cosine double angle identity. Or go back to the original one, the cosine squared minus sine squared. What could I replace sine squared with? Okay, just be careful with your negatives on this one. So it's cosine squared theta minus, and then I'll put it in parentheses, 1 minus cosine squared theta. So when we simplify that, what do we actually end up with? Okay. Everybody okay with 2 cosine squared theta minus 1? You guys see it? Okay. You will want to know all 3 of those, or at least be able to figure out all 3 of those for your cosine double angle formulas. I'm going to say cosine 2 theta equals and leave 3 blanks for you. So you're going to have to know all 3 of them for that, okay? Well, but do you kind of already know them? Right? I mean, with the double angles, they're at least, they come from something you're familiar with. And if you know cosine squared minus sine squared, like, it's not like it's going to take you 7 minutes each to find the other 2 if you forget them. I hope.
How long do you have class?
I think you're going to have 10 minutes. Yeah. Yeah.
If I get, if like someone gets like a 0 on everything on the test, like they get a like 10 or like 100% on the formula, but they get a 10%.
Yes.
So this basically just adds 10. You get it right.
Yes. It also means if you get them all wrong, the highest you could get. Yeah. But it should be like a boost your grade 10%. Okay. All right, let's try tangent double angle here. So So tangent 2 theta, that's tangent of theta plus theta. So what's our formula there?
Theta plus tangent theta minus tangent squared theta.
Yep. So we could simplify that to 2 tangent of theta over 1 minus tangent squared theta. And there's just 1 you have to know for that. Okay, so those are all of your double angle formulas.
When is it useful to know the other two formulas for the cosine 2 theta?
So let's say you're doing a proof and you see that there's a cosine 2 theta somewhere in your proof and the right side only has signs in it. Then I probably want to use the version of it that only has sign in it. So it basically just like saves you a step or two in doing a proof if you know the others. You can still get there with only the original, it's just faster. Yeah.
So on the test, will there be like a proof dedicated to being a double angle one, or will it just be like you kind of just combine them all for all the proofs?
It's just going to be like a proof section.
Okay.
And then you'll have to see like, oh, is this a formula one or is it just a basic proof type one? Yep. Yeah. Yeah, something like that. I don't know what the exact numbers will be, but it will definitely be where you will get to choose some. Yes.
Like the entire proof is possible.
Most of it, not all of it, but a lot of it is the proofs. Yeah. Yep. All right, guys. Let's try one. Okay, you are given sine of theta is equal to 8 over 17. Pi over 2 is less than theta, it's less than pi. We are going to find cosine of 2 theta and sine of 2 theta. All right, so I'll let you jot that down. What do you think we need to start with on this? Draw a triangle. Excellent. So I'm going to go over to the side here. And which quadrant am I drawing this triangle in? Good. Okay. All right. Second quadrant. So here's theta. Sine of theta is 8 over 17. So I know opposite is 8, hypotenuse is 17. Guys, this is actually a Pythagorean triple as well. Does anybody know the other side? 15, yes. And will it be positive 15 or negative 15? Good, okay. All right, so we've got our triangle set up. Let's do cosine of 2 theta first. Okay, when evaluating this, you can pick whichever formula you want. You can use the original one that has both cosine and sine, or pick one of the other ones with only one. I would pick one that only uses sine or cosine just because it's simpler to deal with. So I'm going to use the 1 minus 2 sine squared theta. But it does not matter. You could pick any of the formulas and you would get the same answer. Okay? So 1 minus 2 times, what is the sine of theta? 8 over 17, and then I'm squaring that. That's a 7. Okay, from this point on, it is just math calculations. Like there's no free calc happening here. This is just, can you multiply and add and subtract. So I've got 1 minus 2. We're going to square first. So what's 8 squared?
64.
And what's 17 squared? Is that not one you guys know? Close. 289. All right. Do you guys see the 2's not going to reduce the 289? So I know the 1. What do I want to turn the 1 into? Good. 289 over 289 minus, I can do 2 times the 64, which would be 128 over 289. And what does that become when I subtract? 161 over 289. And again, it does not matter whichever formula you used, you would get to that same point. Well, assuming you picked the cosine formula, okay, not just any formula.
Can you show us how you do the first cosine squared?
Yeah, so if you had done that, so cosine of that would have been negative 15 over 17. I don't know, maybe this one does seem simpler. And then this was 8 over 17. So you just square, so you've got 225 over 289 minus 64. You get the same thing. Yeah, whatever you feel like. All right, and then let's do the sine of 2 theta. The sine formula is just simpler. So sine of 2 theta. What did that equal? 2 sine theta cosine theta. All right, so we're going to have 2 times, what's the sine of theta? Okay, and what's the cosine of theta? All right, so multiplying, I'd probably rather do the 2 times 15 first and then times 8. So then you just have negative 30 times 8. So what do we get? Yep. 289. Okay. If I had asked you a tangent one, same thing. You just plug in the values of tangent from your triangle into the formula. I mean, up to 17 is fair game, I'd say, for squaring things. Well, or, I mean, if you forget, you can certainly do 17 times 17 off to the side if you need to. Okay, but it is, it is a non-calculated part of it. 16 times 16? I should know 16 times 16. Is it? No, isn't it 1, 6? Okay, yeah.
I used to have one.
No, the team ones get a little
We were
weird.
tested on it in geometry class.
Oh, yeah. All right, guys, ready for half angle formulas? You can do it, guys.
I guess.
My. Guys, these we're not going to derive. I'm just going to tell you what they are, okay? They're not as pleasant. 3. The 3 here, and that's it. Yeah. No, there's more notes. Like, it's how to use these after this, but that's it for formulas. Sorry, Milad, what were you saying?
So we had double angles, half angles, adding multiplication.
Sum and difference. And then day 1, we wrote out, like, all the... Yeah, you need your reciprocals and your quotient and your Pythagorean. Okay. You got it. All right, first one, sine of theta over 2. Okay, that's half angle. plus or minus the square root of 1 minus cosine of theta over 2. It's lovely, isn't it?
What?
All right, cosine of theta over 2. It's similar, still plus or minus, big square root, but it's 1 plus cosine theta. Remember I said we're not going to derive these because it's super ugly. These I'm just going to give to you, and you'll just have to use them, okay? Yup. All right, then tangent of theta over 2. My screen's all flashy today. All right, it is 1 minus cosine of theta over 1 plus cosine of theta.
Oh, that makes sense.
It does, because tangent sine over cosine, right? Yeah, okay. Now, you can actually go through a proof to show simpler tangent formulas if you want. So if you want to jot these down, it's also equal to sine of theta over 1 plus cosine theta, or 1 minus cosine theta. Oh, awesome.
It's also square rooted.
They are not square rooted. That's why I said they're simpler. Oh, okay. Try to look. No, it is not four. Now, guys, those tangent ones on the formula sheet, I'm only going to ask you for one. Okay?
So we can use any of the three that you wrote.
Yes. Yep, any of these three would be acceptable. Okay? Yep. I won't give you 3 blanks for tangent. I'll just give you 1 blank. All right, let's look at how we're gonna, yeah, Griffin.
Triangles have the same, or not congruent, whatever it is, where like they all the sides have the same ratios, they have the same values, like the size of the if the ratio between.
If the ratio is the same, yes. Similar triangles, that's what you're thinking of,
Yeah.
yes. Part of that is because they have the same angles. And so I think at sine of 30 degrees, it doesn't matter what the sides are, it would always reduce to the same. All right, let's try. I feel like it looks white when I look at it, and then I turn away. Can't tell. Is it Ford? Okay. Hang in there, guys. All right. Round number 2. All right. Using the half angle formulas, we are going to find the sine of 7 pi over 8. Now let me walk you through this one completely, guys, because it's not super intuitive how you go about it. Yeah. Sometimes, because there are certain ones where you could use double angle or sum or difference, that type of thing.
But if the scissors want to call.
There's some where I will tell you, like, this is what I want you to do. Okay? The screen is out of control today. Like a Christmas light show for you, okay? All right, so we're going to start with writing out what the sine of theta over 2 formula is equal to. So that is the plus or minus big square root of 1 minus cosine theta all over 2. Going to kind of give you some steps off to the side. First thing you have to think about, where is 7 pi over 8? Because that's what I'm asking you about. Like, what quadrant is 7 pi over 8 in? Second quadrant, right? 8 pi over 8 would be pi. So this is just before that. So it is in the second quadrant. Okay. So we're talking about sine of that angle. Is sine positive or negative in the second quadrant?
Negative.
Sine is your y value, right? So that is positive. So we know we're going to be picking the positive in the front of that formula, okay? You have to determine, is the sign positive or negative when you're going through this? Okay. Cosine is negative in the second quadrant, yes. All right, the second step that you have to go through, you need to figure out what is theta. Yeah, if you can't read anything, guys, just ask. I know it's brutal today. All right, so let's think about it. This 7 pi over 8 that you were given, do you guys see how that is the theta over 2?
Yes.
Okay, so then what is theta going to equal? Okay. 7 pi over 4. That's something you actually know from your unit circle, right? Good. That's what should happen. You need theta to be something that you can actually evaluate the sine or the cosine of. Okay?
Is that in the fourth quadrant?
That is in the fourth quadrant, yes. Okay. Now we can actually go back and start evaluating this. So we know we picked positive, so I don't need to write that in front anymore. 1 minus the cosine of, well, what was theta? We found that. Well, it's 7 pi over 4. We'll get to evaluating it in a second here. Let me write that a little bigger. Then it's just a matter of evaluating and simplifying. So you have all that decision making up front, and then we just get to answer it. So what is the cosine of 7 pi over 4? Okay. Lots of fractions. Oh gosh, it's getting worse. I just have to like hold the cord here. I won't move my hand. Okay, think about it. The 1 is over 1, right? So if you were actually combining those, are we okay with, we'd have 2 minus root 2 over 2. That's the top part. Then it's divided by 2. Are we okay with that being the same as times 1/2? Like, look at those two steps. Do we understand what's happening?
Yes.
Good?
You just put each one to 2.
Yep. And the times 1/2 we okay with? I see a few skeptical eyebrows, so are we all right? Ask if you don't see something, okay? All right. You don't have to write this step out. I just want to make sure you guys see all of it. So now I've got 2 minus root 2 all over 4. Can I take the square root of 4?
Yes.
Yeah, what is it? 2. So your answer is square root of 2 minus root 2 over just 2. That 2 is now out of the square root. That is your lovely answer for the sine of 7 pi over 8. You would just leave it. Yeah, it should be. We'll get into one that's not, but the ones where you're actually using the unit circle, they're going to work out nicely.
You need to rationalize all of these.
Not always, because we're getting radicals under radicals, which gets a little tricky. So I'll show you one where you have to. I think I have one in here. Okay? But if they're from your unit circle, they work out nicely. All right, let's try another one of those. I'm going to have you guys try this one. It's a very similar problem. Instead of the sine of 7 pi over 8, you're going to find the cosine of 7 pi over 8. Not the same thing.
Close.
Yeah. It still has a lot of 2's in there, but. All right, so you guys try this one, Greta. Yes, so do the same things we did up here, what I wrote in green. So think about where 7 pi over 8 is. Determine positive or negative after you've written the formula. We know what theta is, and then go through that. So I'd start by writing your formula. Like, begin there, okay?
The cosine, the formula is 1 plus cosine of theta over 2.
Mm-hmm. Are you getting lots of 2's again, guys? 3 2's, I like it.
The way you figure out variables, the worst one.
You did or didn't get the same answer? Uh-oh.
Steve, is there 7 or
315 degrees.
Oh, okay.
Well, over 4 is always going to be over 2.
It's the root 2's over 2.
Okay, cool. And I just have to plug in
My brain doesn't like to go back to degrees. Like, so much easier in radians because all the over 4's are the same.
Yeah.
The over 6's are the same.
Yeah, that would make sense. I just forgot all of it.
Oh dear. Are we ready, guys? Okay. What'd you guys get as an answer?
Negative root 2 plus root 2 over 2.
Yes. This is the answer, if you got there. Negative big square root of 2 plus root 2 all over 2. Okay? How many got there? Okay, I'll still go through it. I just want to see how we did on that. Okay? All right. So you've got your formula. It's plus or minus the square root of 1 plus cosine theta all over 2. Okay, we are thinking about where is 7 pi over 8. So we know it's second quadrant. Is cosine positive or negative in the second quadrant? Negative. So I know I am picking the negative this time. All right, so negative square root 1 plus. Now, the theta we also already found in the last problem. What is our theta equal to? Yes. Okay, now it's a matter of just plugging it in. So cosine of 7 pi over 4, that is positive root 2 over 2, over 2. Then you're just simplifying. You'd have 2 plus root 2 over 2 times 1/2. You can show me that it's 4 in the denominator, or I'm completely fine with you just going to the answer. Negative 2 plus root 2 all over 2. Okay? Questions? Yeah. Yeah, because if I multiplied this out, big square root, and since I can take the square root of that denominator, I'm going to. Yep. Other questions? Okay. Let's look at the half angle one in a slightly different way. I can ask you these questions in different manners. All right, let's try. We're back to a given kind of problem. So we are given that the sine of theta is equal to 5 over 13. And we know pi over 2 is less than theta is less than pi. We're going to find the cosine of theta over 2. Yeah. What do we always do first in the given problems? Triangle, okay.
Oh, that's not fun. No, I mean, but you have to come.
What quadrant should I be drawing my triangle with theta in? Second? Yeah, okay. All right, sine is 5/13, so I know opposite is 5, hypotenuse is 13.
12.
Positive or negative?
Negative.
Negative 12, okay.
Oh, that's so.
Everybody's okay with that?
Yes.
Okay. All right, I'm going to go over here and write out my formula. So cosine of theta over 2, I know that's equal to plus or minus square root of 1 plus cosine of theta over 2. Okay. We know where theta is, but that's not what I'm asking you. So you need to figure out where is theta over 2. Okay. There's a few ways you can do it. One way that I think is pretty easy is go up to this inequality that you have and divide it all by 2. Because if I want to take theta and turn it into theta over 2, to keep everything equivalent, I have to divide the rest of them by 2, right? So now where is theta over 2? Quadrant 1, right? Because it's between pi over 4 and pi over 2? Okay. So this is in quadrant 1. Is cosine positive or negative in quadrant 1? Positive. So we are picking positive for our formula. Now, it's 1 plus cosine of theta. So I've got 1 plus, what is the cosine of theta? We're back to the triangle now. Good. So I'm just going to write 1 minus 12 over 13. And then that's all over 2. And now, again, it's just basic calculations. So what could I make the 1? Okay, 13 over 13 minus 12 over 13. So that is 1 over 13. And then divided by 2 is the same as times 1/2. So I have the square root of 1 over 26. So if I wanted to rationalize that, what?
No.
You sure? Okay. How can I rationalize this, guys? That is your answer. Yeah, and right now you will need to rationalize. Later in the year, I actually won't make you rationalize anymore because there's a lot of calculus you don't have to rationalize. So, do you guys see how this is a question that's asked in a different way than the previous ones? Okay, given the triangle, figuring out where theta is a little different, or where theta over 2 is. So just make sure you recognize like which problem you're actually doing and solve with that method, okay? Yeah.
What about something like 1/4 that's like cosine of 7 pi over 9? Do we get a question like that?
Over 9? Nope. You're only going to get angles that when you set them equal to theta over 2 and solve for theta, they actually equal something on the unit circle. Yep. So it won't be weird ones like
It's
that.
just the ones that are big ones.
Yeah, so if you go to plug in the angle in the formula and it's like 3 pi over 7, like something's gone wrong, okay? Go try again. All right, let's do one more, guys. You will, yes. And guys, let me just give you kind of one more, like, reminder of what does what. When you're looking at theta over 2, that determines the plus or minus in front of the square root, okay? So that tells you plus or minus in front of square root. Whereas the theta, that's the angle used in the formula, okay? Just so you can kind of keep those straight. Whoa. All right, so let's try one more. I'll have you guys try this one. So you are given cosine of theta is equal to -4/5 pi is less than theta is less than 3 pi over 2. And I want you to find tangent of theta over 2. Okay? So try this one for me. theta over 2?
How do you know if it's positive or negative? If it's x axis is going to be positive, like 2 or 1.
So you first need to figure out where is theta over 2. So which quadrant is it? Because you did pi over 2 to 3 pi over 4. Okay, yes. So is tangent positive or negative?
It's negative.
Okay.
It should be negative.
Yes.
Oh,
Yep, that's what you're looking at.
It's sine theta or something.
Exactly. Yep.
The answer.
It's so obvious.
No, but I thought it's faster.
Yes.
And it is negative. Yeah.
Check in with your neighbor. Assuming your neighbor's ready to be checked with.
I know, like, I feel like that was just
The answer is actually kind of nice this time. Okay, good, good.
After you write the word, so you wrote down that's when you look back to the word.
all the time. My brain works faster, but the problem is when I'm reviewing, I'll get confused. So like here, I switched it to plus immediately because I know that's what it is.
Okay.
And I realized that my brain's gonna be completely quiet there, plus then it's gonna take time later. And like here, I
Okay.
that's how I like.
All right, guys, are we ready?
So this is just like.
What'd you get?
Is that great?
3 or negative 3? Which one?
Negative.
It is negative 3. Let's go through it. That's all from the first part there, just picking your quadrant, essentially. Okay, we're going to draw our triangle first.
You don't need to. I didn't do that.
Okay, pi to 3 pi over 2, that's third quadrant, right? That's where theta is. That is not where theta over 2 is. Okay, so theta is down here. Cosine is negative 4/5. What's the other side going to be? Negative 3. Everybody okay with that?
Yeah.
Okay. Find where, remember we need to know where is theta over 2. So you have to go up here and divide everything by 2. So that's pi over 2 is less than theta over 2 is less than 3 pi over 4. What quadrant is that? Griffin, question?
Angle, if theta is in quadrant 3 or 4, doesn't it always end up in quadrant 2?
Yes. Yep. Are we good with quadrant 2 there? Okay. So guys, think about it. Is tangent positive or negative in quadrant 2? Negative. So when we go to do our formula here, the tangent of theta over 2, we're picking the negative. Okay? And you've got, and you can use any of the formulas for this. I don't know why I'm doing this one, but
Why did I do the more complicated?
yeah, sometimes we do.
I just
What's the more complicated?
All right, so do you guys see cosine of theta is negative 4/5? So I'm going to have 1 plus 4/5
Just get rid of that.
over 1 minus 4/5.
But if you, that's not more
Yeah.
complicated. So that's just fucking this out as soon as you have.
That's true.
Oh, true.
All right.
I didn't do that.
So that's 9/5 divided by 1/5. Yes.
Yes.
Okay. So 9/5 times 5 over 1. We just have square root of 9 with a negative out in front. So it is -3. Okay? Make sense? All right. It's tricky going back and forth between the two kinds of problems, but just pay attention to how the question's asked. That's the end of your notes, guys. So here, let me make your homework available. All right, guys, your homework is available in math space.